Hello, here we are, Jeffrey Fox again, and we're now up to lesson 10 of Unit 2, giving a particular example of recommender systems as a key technology of the big data revolution. This is the Big Data Applications and Analytics course, School of Informatics and Computing, Data Science curriculum, and as I say, we're doing the course motivation, lesson 10, Unit 2, section 1. And if we look at many informatics area, one needs some sort of matching of things. Namely, if we're doing purchasing, we want to take people and match items they can purchase to them. And maybe we actually either don't have items, but collections of items or collections of people. So we have various possibilities here. People to products, that's online and offline commerce. People to people, that's social networking. People to jobs, that's things like Monster or something, job sites, matching people to jobs or employers. And then we want to have people plus their queries matched to the internet. That's called search. So all of these are effectively recommendations. You're given an initial query, whether it's the name of a person or the name of a product. You want to find related things in another space. It'd be the space of things to buy, the space of people to know, the space of jobs to apply to, and so on. So that's recommender systems. They're a key technology. Interesting, they're not used nearly as much in science as they are in commodity lifestyle informatics. And the dominant approach is called collaborative filtering, and we'll discuss that in the course. And then also the so-called k-nearest neighbor algorithm, which is one example of how to do collaborative filtering. So we again can give these examples, given some action by the user, what they click on, what they want to buy. You suggest similar things they might buy, because like with Amazon, when you buy something, or with the bookstore, you look at a book, they suggest similar books or similar things to buy. And you can do the same thing with movies, that's Netflix, restaurants to eat at, events to go to, and I say books and movies to buy. You can also do things like Google News, where you try to group sites which are together in various categories and match those categories to users. And there's also some more sophisticated things which real supermarkets and online supermarkets do. You decide on discounts based on information you have on what sells well and what's not selling, and that's again done by an analysis of existing habits. We have at LinkedIn or Facebook. I mean, LinkedIn is always sending me emails about people who I should match to, and so that's an example of identifying people they think are like me or I might be interested in connecting to. And Career Builder and Monster we mentioned already, matches between employers and employees. So this is the basic matching problem which recommender systems. So I've often observed that everything in life is an optimization problem. Life itself is an optimization problem. And you can see survival of the species and things. Species are optimized to solve problems, which when meteorites hit the Earth and change things very rapidly, maybe they can't do. But anyway, and you can say when you live your life, you're optimizing happiness, and so on. When we looked at the physics analysis, the earlier example, I showed a model fitted to the data. That's an optimization problem, finding the parameters of the model. And that gave us the mass of the Higgs. And the result of the optimization problem was some measure of the test of the hypothesis that the Higgs existed and the mass of the Higgs. When I'm matching a user to jobs or books or to other users, that's an optimization problem. I'm finding the best users to match to a given user. Classification is an aspect of this, which is assigning of an ontology, a list of labels, to items, which can be, again, users or books or what have you. So that's an optimization problem. And in optimization, you have a function which you typically minimize or maximize the negative of the function, whatever, however you want to phrase it. Let's call it minimization or optimization. And often the key is to find an ingenious choice of function. Mother Nature's already got a natural function, the so-called free energy, which it gets the equations of physics come from minimizing that free energy. And as a result of this, when you're doing this, as we'll look at later, you often think in these problems as these people or items as points in a space. This space is often a pretty abstract space. It doesn't have vectors with the normal properties with scalar products. Sometimes we call the space a bag. If, like an information retrieval, we often talk about a bag of words. That's words, which to point out that this particular space doesn't have the elegant Euclidean properties of the real-world spaces we're familiar with, but still as a space. And it's good to think of people as, or items and things as a space. Often this space has huge dimension. The number of books on items on Amazon is huge, and therefore a particular items is what you find users interested in is a very large vector. So if we look at, here's a few slides from Netflix, and Netflix says that everything is to do with recommender systems, and everything is data science. And it gives you, this comes from a tutorial they gave, which will go into more detail in the actual course. And it gives recommendations with rankings of things it thinks you might be interested in, and it does that noting perceptively whether you're a household or a user, or it does both together, which is probably the most efficient, because obviously one's children are more interested in different things than you, and so on. So this comes from Netflix. Everything is a recommendation. The ranking is a recommendation, the rating is a recommendation, the row selection is a recommendation, the similarity, and so on. And everything is done to make the user happy, because Netflix's goal is to maximize the money it gets. That money it's getting is typically gotten from users staying on Netflix and ordering more movies, which they pay money to Netflix to download. So it's very important for Netflix that it makes good suggestions. And it has all sorts of information, the context, which is implicit, explicit, what the user actually watched, and also the mix thereof. And it's also reasonably important to know why you made the recommendation. Some of the methods are discounted because they don't tell you why they made it. They're so abstract. And we also need to be certain to be diverse, cover a lot of, we have a giant space. We don't want to put all the points in one space. One part of the space, just choose science fiction. We may want to choose a note to the person, though he loves science fiction, also has other interests. And freshness. We don't always want to suggest the same thing. We need to have changes. Here's some data on Netflix itself. And it's now much bigger than this is actually end of 2011. And there's all these numbers measured in 2 billion hours streamed, 30 million plays a day, 4 million ratings a day, 25 million subscribers, and so on. So, but these numbers are all probably twice as big as they nowadays. And it's actually 29.2 million subscribers in April 2013. And so Netflix keeps growing, and it's one of the success stories of the internet and the companies created to exploit the internet. By the way, Netflix does all its computing on Amazon. All Netflix is hosted on Amazon. They had this very famous competition, which was to improve their rating ratings, and they gave $1 million to the team that won it. This was in 2009. This has gone through the site called Kaggle, which we'll discuss in the lectures. And these group of people here won $1 million. As far as I know, they did not release the result. They did not say actually what their proposal was. Netflix probably kept that proposal internally. They actually did it in a very complicated fashion with, I think, some 100 different machine learning algorithms joined together. So here's this team of great people who won that prize. And notice that Netflix says that data science is important, and they actually say their part of data science is consumer data science. And they start with a hypothesis that a certain approach, a new algorithm for doing ranking, or a new feature of the user interface will increase what they're trying to maximize, member engagement and member retention. Then they design a test, and they test it. So actually, this is the so-called A/B testing, where Netflix will choose a small subset of their users, because they have so many. Remember, they had 25 million or so on, that they will actually take a small subset of those users, probably scattered around, take this new algorithm, test it on that, and see if it actually improves things. Maybe it makes things worse. And they're running all sorts of tests continuously. So they have a pretty interesting way of exploring the future. And it's actually rather hard for academia to replicate this, because academia doesn't have 25 million people listening to what I'm saying. So they have a huge advantage in making quick progress, which is not so easy to know how you match this in academia. You just have to have great ideas which are better than their ideas. So next we will go a little more theoretically on the recommender engines and spaces. And I should point out the technology called MapReduce was very important in implementing recommender engines. Thank you very much.